From this to this. From this to this. Transforming raw steel into the world's most comfortable sleep surface. Join us as we explore Leggett and Platt's inner spring story.
The Idea Center decides to create a new inner spring many different ways. Customer input and input from our sales staff. So a lot of times we sit down with our internal engineers, give them a set parameter and find out what we come up with. Once a concept is developed, a prototype is created right here in our shop. Every prototype has to be approved through our ASTM testing and our own internal standards for testing before we take to production. Once a prototype is approved, it could take up to 3 years before we bring a product to production.
The process of creating an inner spring is greatly enhanced by the investments that we've made corporately in backward integration into the key raw material, and that's steel.
Scrap comes into Sterling in two ways. It comes in either in railroad cars or it's trucked in semi-trailers. They load it into cars, buy the grade of scrap into rail cars, and then it's brought into the scrap bay where, based on whatever recipe we're using, we will use a percentage of each different kind of scrap to make the heat of steel that we need.
Making a heat of steel is just like making a loaf of bread. The team load that scrap. It takes three buckets of scrap to make a heat. The furnace holds actually is rated at 415 ton. It is the largest electric furnace in North America. It takes 3 charges to get the furnace in. We put the primary charge in, and we typically run 20 to 22 minutes on that charge. Another charge comes in, we put it on top, run on it for another 20-22 minutes, and then put the third charge in. We bring the temperature up to typically around 30-20, and the gates open in the bottom of the furnace. We tap the heat. Tapping is when we take the molten material in the furnace and open a gate, and the steel falls through a tap hole into a ladle. In other words, we're taking it from one vessel to another vessel, and that ladle is able to be moved by the ladle crane. The next move is to the ladle metallurgical furnace, or the LMF. What we try to do is bring the temperature up on the ladle and then bring it to where it needed to be for casting. And once we get it up here, a fiber lid is placed on that to hold the heat in there. And that heat then is taken to the caster.
We bring it down to what's called a ladle, and we take it out of the ladle into a holding tub, what's called a tundish. It's like a big bathtub with eight holes in the bottom. They let the steel come out at a certain rate into copper molds that are water cooled. It makes the 5 1/4 bar, and it goes down through the machine at a curve and gets cut by the torches and out into our cooling bed. It takes about an hour as it passes across the cooling bed, getting turned over. Then it's all loaded onto transfer cars and taken over to the rod mill.
We take the billets, they're in piles out in the billet yard, and we'll take the billets off of the correct pile and stack them on the charge conveyor. From that point, they go into our reheat furnace where they're brought up to temperature before rolling. We discharge a billet out of the furnace. It goes into our number 1 stand. We start the reduction. We have what are called box passes, and we basically smash the 5 1/8 billet down. That goes upstairs to the rod block, and in the rod block we have 10 sets of carbide rolls that further reduce the bar down to the finished size. We lay the coil out on the laying head. There we have a series of fans under the conveyor that blow air up through the coils to cool them down. The coils go to the other end of the cooling conveyor into a reform tub where the rings are gathered again and stacked back up into a coil form. It travels around to the inspection area where they attach a tag to it at that point in time. Then they release it. It goes to one of the 2 compactors that we have now that compact the coil, put 4 welded tie wires on it. It comes out of there, goes down to the conveyor. They go clear across to the other bay where they're taken off by the crane and put in a rail car. Many times our product will never touch the ground here. It goes straight across the conveyor and right into the car.
Our steel rod comes from our own rod mill in Sterling, Illinois. They put it on the rail car, and then those rail cars come down to us, and then we use a barcode crane to take the coils out of the cars, set them on the ground. They're all separated by heat number and by size, and then we would take a large pole truck and we will pick the coils up and we'll stack them in stacks. Before we can draw them into wire, what we have to do is bring them in and acid clean the scale and the rust off of them. So what we do, we have 2 large tanks that have sulfuric acid in them, and we will bring the rod in, drop those coils into that acid, and then bring them out. We run them through a static rinse, a high pressure rinse, and then we coat them with something that will go through our wire drawing machines. Most generally that's a borax coating. Once the wire goes through our cleaning process, then we have a material handler that will bring it on a fork truck into the wire drawing room.
This is our wire drawing operation, and what we're doing is taking the hot rolled rods, drawing them through a series of dies down to the finished diameter that we want for the final wire size. And it's collected on a trunk, and with air it's blown down onto the carrier, and it falls down, and then we use a pattern lay. Once the wire comes off the machine, the operator will cut it, take a sample. He will do some testing on it himself. Another sample goes into one of our testing labs.
I pick up the samples about every 20 minutes. I take a micrometer that is calibrated for each individual tester, and I mic it all the way around, and trying to get the high and the low. Then I put that in, and then this is a pencil tester, and so it pulls the wire apart, and that tells you the break load, which is the strength of the wire.
Our specs for inner spring wire are very tight, very strict, much more so than the industry. We will take and bend the wire in a 4-plane bender just to make sure it will do that. If we need to, for certain applications, certain wires, we will take and twist it and count the number of twists that it takes. After the wire goes through testing and is passed, then we will take that wire, put it in our warehouse, and it generally goes to one of our own spring branches. The largest of my customers out of this mill is Branch 1 here in Carthage, just a few blocks away.
The machine that we are currently standing in front of is a Spule machine. It's a Spule CS424. It's made by a company that we own in Switzerland. And this machine right here will run around 120 coils a minute.
So basically they make the adjustments on the screen, they check their adjustments, then they run it through the top and the bottom head, which actually forms the coil into the certain size they want. Then it runs through the heat treater unit, which actually tempers the unit. Then it runs it up into the stacker, which actually runs it down to the belt into the assembly unit.
Once the unit is coming off the back of the machine, the clipper tapes it on the right hand side, then the unit's thrown up on the table, and the clipper is attaching the borders.
We receive it in off the truck, the rod, and it's on the carrier. We take it to the border benders, it's set on there. They straighten it, cut it to length, they bend it, level it together so it's one continuous border. After it's produced, the borders go out to the compartments where they're put on the beds.
Once all 4 corners have been pre-clipped, then the unit's put up on the auto clip to go through the automatic cycle. Once they're done on the auto clip, then the unit is taken off, inspected by the clipper, and hung on the trolley line to go on down through the process.
A mattress submitted by a customer to the Idea Center would generally run standardized ASTM testing. Those tests consist of a Cornell test, a rollator test, ILD or firmness test, and a height check. The Cornell test consists of a 230-pound load of a buddy-shaped platen that runs at 100 cycles per minute and takes about 10 hours to complete. Another test that we run is the rollator test. It's a mainstay in the industry. It's been around forever. It's essentially a 240-pound roller, and it crosses the width of the sample for 100,000 cycles, which is actually 200,000 passes. This test is estimated to be a 10-year evaluation. The ILD or firmness test is essentially a large tensile compression tester. Basically, we have a procedure where we have a specific size platen that we compress into the sample to a specific load, and we can determine a firmness value. The tests we do here that were developed by Leggett and Platt consist of the pressure blanket test and sway force analysis. which is essentially a mannequin on one half of the bed with the rollator acting on the other half. Your mattress, you're going to be in it 1/3 of your life. So it's good to know how it's going to perform, what it's going to do for you.
Leggett and Platt is the leading manufacturer of bedding components throughout the world, not only in terms of numbers, but in terms of diversity of product.